Sound insulation helps block or reduce the amount of noise that travels from one space to another. It is a crucial aspect of good building acoustic design, especially as structures become lighter and transmit sound more effectively than heavy materials such as concrete. To create quiet, comfortable spaces, we need to understand the different types of sound insulation, so airborne, impact, and flanking. Let's break them down. Airborne sound travels through the air as pressure waves. It is the sound of people talking, TV and hi-fi systems playing, dogs barking, music blasting from the next room, road, rail or air traffic noise, building services, etc. These sounds can pass through walls, floors, ceilings, and building facades if the building isn't properly insulated. You can reduce the airborne sound transmission through a building element by using several strategies. You can first increase the mass with heavy or dense materials to block and reflect sound waves. You can use cavities or air gaps within the build-ups. You can fill these cavities with light, sound-absorbing materials to stop the resonance happening in the cavities. And by the way, it is also commonly referred as sound insulation, but the term is misused and it is effectively sound absorption. One other solution is to use acoustic resilient fixings to interrupt the vibration transfer from one side of a structure to the other. And finally, you need to seal all gaps, cracks and joints around all and within partitions because even small openings or holes can dramatically reduce the airborne sound insulation performance of a partition. If you do not apply these measures properly, airborne sound can quickly pass between rooms and undermine privacy and comfort. Now, impact sound insulation. Impact sound occurs when something physically strikes a building surface and sets it vibrating. These vibrations then travel through the structure and radiate as sound in other spaces rather than moving mainly through the air like airborne sound. In buildings with a light structure like steel frame or timber frame, this effect is more pronounced because the light structures tend to better transmit vibrations, so impact noise can spread better from one room to another. Examples of impact sound include footsteps on a hard floor, a ball bouncing, a chair scraping across the room, heavy rain on a lightweight roof, activities in gyms and sports areas that involve dropped free weights, jumping or also treadmills. To reduce impact sound, you can add soft layers such as acoustic mats or rubber on or beneath the floor finish to absorb the impact and reduce vibration transmission. You can also install floating floors that sit on acoustic resilient layers or isolators and are separated from the main structure so vibrations do not pass directly into the timber. And finally, you can focus on decoupling key elements or making them discontinuous like floors, ceilings and sometimes walls so that impacts do not transmit straight through the building frame. And finally, flanking sound insulation. Flanking means something that travels indirectly going around, over or under a main barrier rather than passing straight through it. In acoustics, flanking occurs when sound energy bypasses the primary insulation, like a wall or a floor, by moving through alternative paths such as adjacent structural elements, gaps, junctions, etc. Flanking sound happens around partitions, between floorboards, along steelwork, via wall junctions, through small cracks and gaps, via ducts and other building services, or via building structures. For example, even if a wall is thick and well insulated, its overall airborne sound insulation can still be poor if the flanking transmissions are not properly controlled. Another example is in timber buildings, where elements are tightly connected and where lighter materials are used. Vibrations and sound transfer more easily, so controlling flanking paths is just as important as treating airborne and impact sound. To reduce flanking sound, general rules include carefully designing connections to avoid continuous sound paths. You can also use acoustic resin layers or breaks between walls, floors and ceilings. And finally, you need to pay close attention to every single junction, edge and detail during construction. Thank you for watching this video. If you enjoyed it, don't forget to like it and leave a comment. You can also subscribe to our channel. It really helps us grow and produce quality content. And finally, we gather all our content into small online courses that you can take as personal training and get a certificate at the end of it. You can access them by following the link in the description. See you later.